Okay, this is part 6. This is life in the water. Most aquatic species live in top, middle, or bottom layers of the waters. I wonder what's left after that. But just kidding. Okay, so plankton are weakly swimming, free-floating organisms. They usually swim about less than 1 mile per hour or so. The three types are phytoplankton, zooplankton, and ultraplankton. A lot of people lump your ultraplankton and phytoplankton together. Just know phyto means light, so they are photosynthetic in their air, or they are plant-like. And zooplankton, these can be single-celled to jellyfish. Because remember, as long as they are free-floating or they are weakly swimming, they can be considered zooplankton. And your ultraplankton are photosynthetic bacteria, and this makes up 70% of the ocean's NPP. And remember, this does have the open ocean has a high level of NPP, but that's simply because it's so vast. It's such a large area, whereas it's your coastal areas that have the most jam-packed per unit area. Nekton are strongly swimming consumers. Benthos are bottom dwellers, and decomposers usually are found at the bottom as well because they are decomposing the detritus, the marine snow that is trickling down. Effective nutrient enrichment on a lake. Remember, on the left, this is your oligotrophic lake. So this one's going to have very low sediments, and it's going to be very clear. So therefore, you're going to have very little MPP being produced in this lake. The one on the right, that is your, basically this one has your eutrophication in it because of the MPP that is, you can see there, oligotrophic is this one. And you can see the MPP that's happening there. And this is basically cultural eutrophication. Remember this because excess eutrophication, this is, remember, hyper-eutrophication. This is basically where you had the runoff from agriculture is going to add excessive nutrients to the system. And then after that, you have uninhibited plant growth and algae. But then you know what? The nutrients aren't going to last forever. Usually it's after a big flood, a big rain, or ice melt after the winter. So in the springtime, usually when you have this influx of nutrients. And then you are going to have, where did I leave off? Aerobic bacteria will break down those dead organisms, and they are going to use up the oxygen in the process, and therefore fish will die. 3 zones are your source zone, transition zone, floodplain, and this is of a moving river. Now, typically, I leave out the characteristics of your transition zone and just focus on source and floodplain because transition is just intermediate of the two of them. So your source zone, let me make sure it's not here. Okay, your source zone is going to have very cold. See, look here. The source zone is coming from the melt, rain and snow melt, so it's going to be cold. It's going to be very shallow, and it's going to be bumpy. You know, the water's going to be rushing down on very shallow rocks, and so you're going to have a lot of stirring up and mixing of oxygen, from atmospheric oxygen into the water. So that's going to create a high DO. It's going to be very narrow, very shallow, low MPP. Whereas as you come down to the floodplain, it's going to be deeper. You're going to have a lot more sediment deposited, a lot more nutrients. So you're going to have more MPP. It's going to be warmer, wider, and down here you can see where it ends up dumping down into the delta. Okay, natural capital, major life zones and vertical zones in the ocean. Look here, you see the stratification here. Remember, just layers. As you come out from the side here, you have your coastal zone. And remember, per unit area, the coastal zone is going to have more MPP, but the open ocean is just so vast that overall it does end up having more net primary productivity or photosynthesis occur. And from the top, you have your euphotic zone. Remember, U, true sunlight. This is the area where the sun hits. Your baffle zone, this is going to be actually where a lot of your zooplankton live. And then at night, the zooplankton will go up to the euphotic zone to prey and eat the phytoplankton. But then you have your abyssal zone, and very, very cold, low dissolved oxygen down here. And this is where going to be a lot of your filter feeders and your decomposers live. And I want to point this out to you right here. This line right here, this is a very, very sharp decrease in temperature. That is a thermocline. Okay, some components of interactions in salt marsh ecosystem. Temperate. Yeah, this is significant because this is where we live in coastal Georgia. A lot of you travel there for vacation. You see a coastal ecosystem right here, and this is a salt marsh. And if we take a boat on the salt marshes at Skidaway, you'll see dolphins, so that's fun. But this Spartina grass is significant because it filters out and purifies water for us, helps purify sediment out, it helps purify too many excess nutrients, and it helps purify the water. Also, a very important spawning ground. Marine and terrestrial organisms will spawn there, lay eggs. View of estuary from space. Very unique environment because of the salinity. It's saltier than freshwater, but less saline than the ocean. So that's why you have unique organisms that are adapted to that particular salinity. Dead zone. Okay, so the dead zone basically, if you can see, where's my pointer? See right here. So this is where the Mississippi River, remember Mississippi Basin, way up here is where a lot of our agriculture land, our grasslands, our prairies, they will dump into the Mississippi River. So during the springtime, when you have all that cold water rushing down through Nolens, it's going to dump here at the mouth of the Mississippi River and create a dead zone, just like the cultural eutrophication. So in other words, what's going on, and along with that cold water, it is forcing, here you go, the cold water is going to basically force the dead algae to sink to the bottom where it's saltier and decompose. So over here you can tell where you have that fresh river water. It's really cold too, but the water temperature is hot. So this creates a barrier layer, cutting off the saltier water. Then over here, the nitrogen and phosphorus from fertilizer and sewage are going to create the algal blooms, and then you're going to have your your bacteria, aerobic bacteria, are going to decompose it. And what they've noticed though is that during this time, when this happens over the summer, the fishermen have to go farther and farther out, and that is problematic for our pocketbooks and this whole ecosystem. It gets better by September though. Oh, did that one fast. Awesome.